This is the Synthetic Signal Report for Wednesday, June 24th, 2026, in the afternoon. Today, we analyze the collaborative development of a specialized AI inference processor by OpenAI and Broadcom, the geopolitical fallout regarding the NSA and Anthropic, Google's new computer use capabilities in Gemini 3.5 Flash, and the acquisition of the AI software firm Modular by Qualcomm. OpenAI and Broadcom have officially announced a custom chip, internally codenamed Jalapeno. This hardware is designed specifically for large language model inference at scale. Built through an aggressive 9-month development cycle, the chip is a reticle-sized application-specific integrated circuit, or ASIC. The primary goal is to address the massive demand for compute resources while moving away from a total reliance on general-purpose graphics processing units. By focusing on inference, OpenAI aims to optimize performance per watt metrics, which have become the primary bottleneck for massive, real-time AI deployments. This move signals a vertical integration strategy, intended to lower long-term infrastructure costs as model usage continues to surge. The National Security Agency has reportedly lost access to an internal project known as Mythos, following an escalating dispute with Anthropic. Reports suggest the friction stems from disagreements over data isolation protocols and the degree of control granted to government researchers within the model's training environment. Mythos was intended to function as a secure, sandbox-ready model for defense intelligence, but the breakdown highlights a recurring tension between private AI developers and national security entities. The loss of access underscores the challenges of integrating advanced, high-security AI capabilities into existing government frameworks without compromising proprietary safety architectures. Google has introduced a new suite of computer use capabilities within Gemini 3.5 Flash. This update allows the model to interact with graphical user interfaces, interpret screen elements, and execute actions, such as clicking buttons or inputting text, much like a human user. Unlike previous iterations that relied on textual APIs, this model observes the screen directly. This development is significant for automation workflows, where legacy software lacks accessible programming interfaces. However, it also expands the potential surface for input-based vulnerabilities, as the model's ability to interpret and manipulate visual environments could be exploited if malicious content is displayed on a host system.
Qualcomm has confirmed its acquisition of Modular, the firm behind the Mojo programming language and the MAX engine. This acquisition is a strategic maneuver to bolster Qualcomm's standing in the AI hardware market. Modular's expertise in compiler technology and AI model optimization will likely be integrated into Qualcomm's Snapdragon platforms. For hardware developers, this integration aims to bridge the gap between high-level AI frameworks and silicon-level efficiency, specifically targeting edge devices that require complex inference without cloud connectivity. Community sentiment today is heavily concentrated on hardware efficiency and AI integration. First, developers are discussing the Jalapeno announcement with skepticism regarding the timeline, questioning whether a 9-month development cycle can truly outpace the rapid iteration of general-purpose chips like those from NVIDIA. Second, there is significant focus on the new Nub toolkit, a bun-like all-in-one project for Node.js. Community members note that its use of a preload hook to inject polyfills for new web standards makes it a notable tool for developers looking to modernize aging Node environments without refactoring entire codebases. Third, we track the emerging tool Awesome Evals by the Bench Flow AI project. It is currently gaining traction as a resource for non-biased benchmarks for AI agents, providing a much-needed repository for researchers to compare models on actual performance rather than marketing claims. Finally, security discussions remain fixated on the high volume of critical vulnerabilities in GOGS, the self-hosted Git service. Multiple reports of unauthenticated information disclosure and privilege escalation have led many to suggest that small, self-hosted teams move toward more robust, managed Git infrastructure to mitigate the risk of continuous patching cycles.